Good morning, everyone. Today I'm going to start with the introduction of the control system. So, this is the lecture one of PCI 501 control system. It is taught in the third year EIE in system. So, introduction to control system. What is a control system? So, every day in our day-to-day life, that we have different sorts of examples of control systems. From home heating system to bathroom toilet fan to a refrigerator to an air conditioner and also an automobile. In every aspect, we use the control system in daily life, knowingly or unknowingly. So here we have this subject which describes that how we are using the systems in our day-to-day life as well as where in industry we can apply control system and where we have the entire system to be controlled for different types of parameters that we have. In industry, for control, the control system is used for quality control of manufactured products, automatic assembly line, machine tool control, and in space technology, it is used also in weapon systems as well as in power systems, robotics. The scope of the subject is that here we deal with the control of engineering systems that are governed by the laws of physics and are therefore called physical systems. We have different terms like process, plant, control system, open loop system, closed loop system, feedback system, set point, manipulated variable, error signal. In a general process control, we have we have different types of systems, and I will show you a basic block diagram of the control system. If you need to control a particular block, process block for different types of variables, if this is the process block we have, this is the process block we have, then this particular process has different types of parameters to be controlled. It may be flow, it may be level, it may be some other parameters. So these parameters have to be controlled. So here the process has the parameters which needs to be controlled, and here is I am presenting you a basic block diagram of a process control loop. So considering this one, if we say that a particular process has a particular output, if we say that there is a particular output. So this output when feed back to a particular system known as the measured system or the measured variables or the measured blocks. So here we have the measured blocks, measurement blocks, or measurement blocks. Then these blocks measure the entire parameters of this process. That may be flow, that may be other systems, that may be other parameters, flow, then level, pressure, temperature, and etc. There could be different types of variables which has to be measured. So on measurement, we have to give on measurement we have to compare this particular measured variable with the input that we are generally known that is known as set point. That is known as set point. So this set point when compared to the measured value directly from the process, okay, has to be given wherein a block has to be given to a block which is known as the controller. So this the difference between the set point and the measured value will be known as error. So this error has to be fed as an input to the controller. This controller cannot directly act upon a particular process. So it has to be given an intermediate block which will act on the process. This intermediate block is known as final control element. This is the final control element block, or this is also known as control valve. So in this one, this particular block diagram, this is known as the basic process block diagram of any kind of system which has to be controlled. So coming back to the PPT, so these are the terms, various terms that are used, like process, as I have described, plant, control system, open loop system, closed loop system, feedback system, set point, manipulated variable, error signal. So all these are different terms that are described with respect to a particular process block diagram. Now, what to control in a process? I have already described this one: temperature, flow rate, liquid levels in vessels, pressure, humidity, chemical composition. These all are to be controlled. So, in a process industry like steam power, chemical fuel, petroleum, we need to control all these parameters, and these are known as process control applications. The theory of servomechanics. It is aimed mainly at applications where it is need to control mechanical motion like position, velocity, or acceleration. The servo mechanism is used for command following systems wherein the control attribute of the system is required to follow a given set point, like the previous one that I have described, that we have given a set point and the output needs to follow the set point. That type of following the set point or following the input or the command, that is known as the servo mechanism. We have another type of system, that is the regulatory system. A regulatory system is a feedback control system in which the reference input or the command is constant for a long period of time, often for the entire time interval during which the system is operational. The difference is that the primary function of the regulator is usually to maintain a constant control output, while that of a servo mechanism is to mostly often to cause the output of the system to follow a varying input. So these are the basic differences. There are different types of examples of regulatory system. Controlling the temperature of a room, in which controlling the temperature of the room, and also like electrical power generation. Like electrical power generation reference or the set point is 220 volt and 50 hertz, that is fixed. But the problem is to maintain this set point in spite of the continuously changing varying demand loads. We have these other there, that elimination of disturbances, that is regulatory control, making the control variable follow the set point changes, that is the servo control. So I'll show you these type of thing is known as the input output configuration. Here we have the input, manipulated input, we have the disturbance input, and the response is here. And this is input output configuration of a controlled system wherein a controller is given as an input. The input is given to a controller, and whereas this output from the controller is given to a process which has a disturbance as an input. A feedback control system. Feedback control system, a system that maintains a prescribed relationship between the output and the reference input. and using the difference as a means of control is a feedback system. Example, the human body is a very highly advanced feedback control system. It is also known as closed loop control system, open loop control system. Those systems in which the output has no effect on the control action are known as the out open loop control system. In an open loop control system, the output is neither measured nor fed back for comparison with the input. Like the general applications that we do in home systems, like washing machine, toaster, etc., are the general examples of open loop system. Another thing is that the open loop system, we have the set point. We generally give the set point in terms of time, like in toaster we give 1 minute to toast a particular bread. So wherever the condition comes, like with respect to time, that becomes the open loop system. That means we are not taking any other kind of variable as a mm, parameter, or variable as a parameter to control that particular parameter. We are taking time as a parameter, then it becomes the open loop system. Advantages Advantages: the simple construction and the ease of maintenance in open loop system. It are less expensive than that of the closed loop system. There is no stability problem in open loop system under certain circumstances where no disturbances exist and the output is hard to measure. Open loop systems may be desired. Disturbances and changes in calibrations cause errors. It has the disadvantage of that one, and the output may be different from what it is desired. To maintain the required quality of output, recalibration is necessary from time to time. So these are the different advantages and disadvantages of open loop system. Here is a diagram of a residential heating system and different types of control systems. Automobile driving control system. So in this automobile driving control system, uh, here different types of input and output considerations are there. Considering the vehicle as the process to control, so it has the two types of parameters that needs to be controlled. One is the direction and the speed that needs to be controlled. So these are given input to the input side, and from the set point value that we have, like for the direction, we have the particular path of the road, that will be the direction, and the speed limits that we have in the road, that will serve as the input. So here these all things are generally detected by we have the detector, the eyes. So that eyes will compare. Generally, it will compare and act as a comparator and give the error signal to the control logic, that is the that is built in the brain. So brain is actually acting as the controller in this particular system, and your hands and foot will be there for the steering position of the wheel for the hands, and the foot will be for the accelerator or the brake of the vehicle, that will serve as the manipulated variable to the process. The process is the vehicle, and the disturbance, the different types of disturbances like wind and traffic disturbances will be treated as a disturbance for the process, that is the vehicle. So this is an automobile driving system, which is basically we are generally have a control system or a feedback system or a closed loop system. Different terms of a control system, feedback control system. So different elements, the basic structure are here. This is the controller block. This is the plant block. This is the feedback block, and this is the set point value. This is the output variables. Different types of signals and elements are noted here. The characteristics of feedback is that uh, it has an increased accuracy. These are the advantages. Tendency towards oscillation and also the instability. Generally, there is no stability problem in open loop system. However, there are stability problems in closed loop system. Also, the reduced effect of nonlinearity is the characteristics of a feedback control system. It is insensitive to external disturbances and internal variations in system parameters. Also, it has a reduced sensitivity and increased bandwidth. These are the different characteristics of a feedback control system. Types of control system can come up as manual or automatic. control system, single variable or multivariable control system, analog or digital control system, open loop or closed loop control system. So the single, depending on the different types of inputs, we have the classification as CISO system and NEMO system. A CISO system means single input, single output system, and a NEMO system means multiple input, multiple output system. A system may have only one input and one output, that is the CISO system, and multiple input, multiple output will be termed as NEMO system. This is an example of level control system. So this is a particular thing where the manual operation is there, that there is an indicator over here onto the vessel, and looking onto the indicator, a person manually operates this particular valve in order to control the level of this particular tank. However, in this is a automatic control system where there is a level transmitter. It will transmit the level of the vessel to the controller, and the controller will compare the level measurement, measured level, with the set point value that is given by the controller, and that um, error will be sent to the particular controller, and the controller will act upon this control valve, which will open or close the particular percentage of opening or closing, depending on this particular level that is measured. So this is a operation that is manual system, manual control system, whereas this one is an automatic control system. So this is the same as that of the previous one. Human operated liquid level system, that the brain is acting as the controller, that brain of the person who is handling the um, control valve over there. So that brain of that particular person is operating as the controller. His muscles or his hands will as the act as the control valve or the final control element, which will open or close the valve of the water tank. So water tank is the process, and the level of that particular water tank will be the variable to be controlled. So here is the temperature controller of passenger compartment of a car. Examples of servo mechanism of steering of antenna. Different types of other systems are also given. Many more systems are presented over here. So we have in this particular STEM, what we have to study is that the different types of analysis of control system. Generally, the linear control system we will study, and in the control system, we have to analyze and design different control system configuration. Analysis will be based on different types of methods that we have, stability problems and transient analysis that has to be done with different types of methods that are available. Also, the design of the compensator that will be done after studying different types of methods of time response analysis. Here is an assignment for the students that name some applications of control theory in non-engineering fields, and also list some advantages and disadvantages of open loop and control system. 3 and 4, the students will do as a true false. So test their knowledge in the basic control system or introduction to control system. So complete the assignment. So this this was the basic lecture on introduction to control system. Thank you all.